Hello, this is Group 8's presentation on Chapter 1 and Fundamental Data Types. The language C. Conceived and implemented by Dennis Ritchie at Bell Labs in the early 1970s. C had features that were ideal for computer hardware, and writing computer programs required less memory. Compilers for C were developed for a variety of machines, making C a popular alternative to assembly languages for a system programmer. Because the C language was too concise for our understanding, it made programs more error-prone due to the lack of runtime checks from system programmers. The development of C++. Derived from the C language, C++ introduced object-oriented programming, causing some confusion for early programmers. This is mainly due to the differences in logic in object-oriented programming to that of the top-down structural style of C. There are two main I/O libraries in common use to this day. The earlier CIO library had become incompatible with the new object-oriented functions in C++. Therefore, a newer redefined stream I/O was created. C++ also produces fewer runtime checks than Java. This is mainly due to the liberal environment in C++. The legacy problem. Much of the difficulty dealing with C++ has to do with legacy code. Legacy code is software written for earlier systems or libraries. Because of this problem, C++ programmers must not only learn the current practices, but also be familiar with the practices of the past. The language Java. Created by James Gosling, Java contained much of the basic syntax of C++ in order to ensure that those who had lots of experience with C++ would feel comfortable with the new language. Many have said that Java programs execute slowly. This is because a program in execution does more work than a C++ program. Garbage collection, multi-thread management, and runtime checks require execution time. And although runtime costs are necessitated by Java, it provides more opportunities for improvement by a good optimizing compiler than that of C++. The better language? We cannot say that one language is better than the other. In the end, C++ and Java should be appreciated for the good qualities that each one has when addressing problems they are expected to solve. Fundamental data types. Both C++ and Java have an integer type, and it can be short or long. There are three types of integers: short int, long int. For example, int normal can store up to a 32-bit value, short int a can store up to a 16-bit value, and long int b can store up to a 64-bit value. Therefore, typically, an int can hold a greater range than a short int, and a long int can hold a greater range than an int. In C++, you can also declare short and long integer values in a shortened form without the int keyword. All three types have a signed and unsigned form. Unsigned form always assigns positive values. For example, an unsigned 16-bit value will range from 0 to 65,535. In contrast, signed form will assign a value between negative 32,768 and 32,767. There will be an error if an unsigned value is assigned a negative number. For example, int n is assigned negative 3. Unsigned int a is assigned the value of n, which stores a negative value. This will display an error. Integer division will always return only an integer type and will truncate the floating point values. For example, 5 divided by 2 will return the answer 2 and not 2.5. 5 divided by negative 2 will return negative 2 or negative 3 depending on the machine. Characters. A char value in C++ is typically an 8-bit quantity. Assigning the character value 2 to a char identifier can be done in multiple ways. For example, 2 placed in single quotes can have the same effect as assigning the decimal value 50, which is a representation from the ASCII table. Floating point values. In C++, there are three main data types for storing floating point values: float, double, and long double. In Java, there is only a float and a double. Both C++ and Java need this type for storing large numbers or values which require more accuracy. C++ has more flexibility for handling floating points. For example, it is illegal in Java to assign a floating point value to an integer value without a typecast, but we can assign them in C++. For example, int I is declared. Double D is initialized to 3.14. I is then assigned the value of D, which in this case is simply 3. The void type. The void type specifies an empty set for a given value. It can be used as a return type for a function that does not return a value. In C++, the void type can also be used as a pointer type to point to any address regardless of its data type. This concludes the presentation, and thank you for watching.